Hey guys, welcome to our first video of the unit. We're going to talk about simplifying trig expressions. On a personal note, this is one of my favorite things to do in math. No, that doesn't make me a nerd. But honestly, simplifying trig expressions is really, really fun in my opinion. We're going to start off with some expression. Notice that the fact that this is an expression is because it does not have an equal sign. And we're going to use what we know and basic algebra skills and use, trig identities that we're already aware of, such as, the reciprocal identities, quotient, Pythagorean, and we're just going to simplify this to something else. The tricky part is that sometimes we don't know when we're done. Like maybe there's more that we could do, but I think you guys will find this entertaining. Okay, so let's start this first one. This one's fairly simple. I have the tangent of x times the cosecant of x. Now I'm just trying to simplify this. So let's think about what tangent of x is. That's sine of x over cosine of x. And cosecant of x is really 1 over sine of x. Well, these are going to cancel, and notice that I'm left with 1 over cosine of x, which last but not least, I can simplify to secant of x. Notice that I didn't put any equal signs here because this is an expression, not an equation. Okay. Let's look at this example. There are several ways that we can simplify this. One could be to distribute. One could be to kind of use our properties. Maybe this is kind of making you think of something right away. Just make sure, although there are several ways to solve this, or simplify this, I should say, you just want to make sure you're not breaking any algebraic rules. So let's see here. Okay, well, this we recognize it's one of our Pythagorean identities. That's sine squared of x times, once again, this is 1 over sine of x. I could simplify here, and I get sine of x. Like I was saying, there is another way I could do this. Maybe if I distribute this cosecant of x and then kind of work from there, I should get the same thing as sine of x. There's multiple ways to do it. Again, just make sure you're not breaking any rules. Okay, let's have you guys try this one on your own, and I'll give you a hint. My hint is that this pi over 2 minus x should make you think of cofunction identities. All right, let's have you guys try this on your own. Go ahead and put me on pause. All right, so my hint to you was that we have cofunction identities here, that pi over 2 minus x should be a big indicator of that right away. So sine of pi over 2 minus x is cosine of x. Likewise for sine and cosine here. Cosine over sine of x is cotangent of x. Next example. All right, so we have a couple more examples here, and it says simplify the trig expression, and the hint is to factor. So let's have you guys try this one on your own. I think you might have some ideas here. Okay, then unpause me, try 1 and 2, and then we'll check our work for both of them. All right, go ahead, put me on pause. All right, who's fired up? That was fun. I'm telling you, these are my favorite things to do. Seriously, I'm just like, I could keep going on and on. I hope we have more problems. Okay, so my hint was to factor here. Perhaps you took out a GCF of tan squared of x. Ooh, tangent squared of x. Why would I say tan squared of x? All right, anyway, I see here I have a Pythagorean identity. If I kind of expand this, I know tangent squared of x is sine squared of x over cosine squared of x. Simplify, and I get sine squared of x. Man, I can talk really fast sometimes. Okay. This next one, again, I want to factor it. I'm noticing here, this actually is a perfect trinomial square. If you don't know what that means, then, well, that's interesting. This does factor nicely. That's cotangent squared of x plus 1 squared, or times itself again, which both of these are a Pythagorean identity. Come on. And so I get cosecant to the 4th of x. Cosecant of x. I know, those were wild. Super duper fun. Let's keep doing it. All right, simplify. Same thing here. this is going to be a really good example when we don't exactly know when it's most simplified. There really are three potential good answers here. So, if you get to one, obviously that's great. But, just do the best you can in terms of knowing when it's most simplified. Some people say when we just have one trig function. Yeah, you'll know what I'm talking about once we get there. So, have you guys try 1 and 2 and 1 and 2? Okay, go ahead, put me on pause. Okay, so I started off by factoring here. This is a difference of two squares. I recognize that this is a Pythagorean identity, which is just 1. So here's that example where I said, there are three potential answers. It's hard to know when we're exactly done. Some people might say, okay, well, this is, as far as we can go. We can put it in either of these two forms, just using our Pythagorean identity here. Some people might say that this is simpler because we only have one trig function compared to two. Any three of these would be fine. For that second example here, notice that we have, again, a difference of two squares in the numerator, so I can factor that. One of my numerator factors cancels out with my denominator, so I get secant of x plus 1. All right, let's have you guys try this next one. My hint for you is multiply this by the conjugate. All right, let's see what you can do. All right, now if this one didn't get you pumped up, then there's nothing I can do. This one was freaking awesome. Okay, so like I said, I would multiply this part of the expression by the conjugate of the denominator, which is 1 minus sine of x. Note, I could have also had a different first step. I could have also gone a common denominator first and then simplified, but I like this way. So I did that, and I got this part here. Although 1 minus sine squared of x is cosine squared of x, what? Now I can cancel out a cosine of x in both the numerator and denominator. And since I have 1 minus sine of x all over cosine of x, I can actually split up those two terms. Be careful about the negative in front here. Once I do that, oh my goodness, the secants of x both cancel out, and I'm left with just tangent of x. It's wild. Okay, a final example for this video. It says, perform the substitution to write the algebraic expression as a trig expression in terms of theta. This is not a trick question. You can do this. So the square root of x squared plus 100, we want to substitute x equals 10 tangent theta. Go ahead, try this, do this, love it, giddy up. All right, this problem is also an example of a fun time in math. So we substitute 10 tangent of theta in for x, and I square both terms because that's what we do. Then if I factor out a GCF of 100, now I have a product, which is good. I like that. But tangent squared of theta plus 1 is secant squared of theta. Now I have two square terms, perfect squares, being square rooted, so I get 10 secant of theta. I hope you enjoyed this video as much as I did.